This is our second lesson on graphing quadratics. We learned everything in standard form from our previous one. This one's going to be in vertex form and intercept form. It's going to show you two different ways to manipulate the equation and make it a little easier for graphing. Again, you want to be able to use all three methods, but again, the objective of this one is graphing using vertex form, and also we're going to show you an example of intercept form. Okay. What is vertex form? Let's just first look at the parent graph. F of x is equal to x squared. All right, so if I graph this in red, I have a starting point at 0, 0. I go over 1, up 1, over 1, up 3, over 1, up 5. And I could do the same on the left-hand side as well. And this is basically our mother graph where all parabolas follow this curve. Okay. What we want to do is, now I'm going to work in blue, vertex form, is if we can get the equation to look like this, where we still have a squared term, so it's still quadratic, but notice we still have the a value. That tells us the scale and the direction. But we have this x minus h plus k. This is very similar to when we had absolute values. Remember absolute value, we had like f of x is equal to, and again, we didn't worry too much about an a, but you could, absolute value of x minus h plus k. And we talked about the starting point, the vertex, is at h comma k, where the h is the horizontal shift and the k is the vertical shift. So let's say I came up with a graph like this. I'm just going to make up a random point here. And let's say this was my vertex and the curve was going down. Over 1, down 1, over 1, down 3, and then so forth. And it's actually down here a little bit. It curves this way, and it's going to curve this way down here as well. Okay. So this point right here is h comma k, which in our case is over 3 down 2. And our slope here is -1, okay, the a value. So how would I write this in vertex form? Very quickly, okay? I don't have to like factor it out or multiply it out. I simply say, well, the function is equal to a value, -1, and we have x minus 3 squared plus a -2. I can just write it like this. So that is the equation of that curve. So again, vertex form is a friendly version because it gets right to the heart of the vertex, and we can see the direction, the placement, everything very easily. So the question is, how do we get it into vertex form? Well, we complete the square. So we're going to see that here in the next two examples. So let's take a look at this example here. Notice we have x squared plus 10x plus 23. So we could do -b over 2a and everything we did from previous lesson, but I'm going to complete the square and put it in vertex form. Now, I'm going to keep this f of x. I'm going to do completing the square just a little bit different, so follow along here. Again, I want to get x squared plus 10x plus a blank. This is what I want, and that's what I want to focus on. But instead of moving the 23 to the other side, I'm just going to push it off to the side and put it over here. Okay. Now, obviously, if I add a blank to this side, I could add a blank to the left-hand side. But I'm not going to do that. Instead of adding a blank to the other side of the equation, can't I put a minus blank on the same side? So if I add a certain number and then right behind it subtract it, I haven't changed the equation. All I'm doing is isolating the parentheses and putting the leftover numbers on the outside. So now, what's the next step of completing a square? Well, you take half of the 10 and make it a 5, square it. So 5 squared is 25. So if I add 25 to the right-hand side of the equation, and then I follow it up with a subtraction of 25, those two numbers cancel out, and we're back balanced again. So we have positive 23 minus 25 is -2. And notice in simply 2 steps, we've now successfully completed a square. And now if I say graph it, no big deal. My vertex is the opposite of 5, because again, we have this minus h, comma -2. And my a value is 1. I could throw that in there. So there's my a value. And let's put that there. So let's just write it a different way. So the a value is simply 1. So I'm going to start at -5, -2. We have an a value of 1. So I'm going to go axis of symmetry, up 1, or over 1, up 1, over 1, up 3. Okay. And likewise, I have a intercept at 0, 23. So somewhere way up there is my line intercept, which makes sense. And just put a couple more points in here, up 5, and so forth. So again, it's going to get a little steeper as it goes up. and we can very quickly graph this curve with a good degree of accuracy. Okay? So completing a square also yields us into vertex form. This has to do with translation. So notice the same parent graph, this shifted over 5 down 2, and that's all we've done. So we're really talking about translations here, and that's what vertex form does. Let's look at one more example. So here, notice we have a 5. So what do? We factor out the 5, and we have x squared plus 6x plus a blank. And again, I'm just going to put the 41 on the outside and follow it up with a minus blank. So next step is, what do I put here? Well, we take half of 6, and we square it, which is going to be 9. Now, obviously, we have a 5 on the outside and a 9 on the inside. So by adding 9 inside the parentheses, I have to multiply it by the 5 on the outside, and I'm really adding 45 to the equation, which causes us to then subtract 45 right behind it. And then we can say, all right, positive 41 minus 45 is a positive negative 4. And if I want to clean it up, no big deal. X plus 3, I think a lot of people just prefer to write it like that. But notice, again, within a couple steps, we're back in vertex form. So my A value is simply 5. Okay, it's really stretched out vertically, and we have a starting point of negative 3 comma negative 4 vertex. So I'm going to graph this now. Negative 3, negative 4, a slope of 5. So again, I'm going to put in my axis of symmetry, and I'm going to go over 1, but now up 5. So again, my stepping scale is 1, 3, 5, 7. But now I'm multiplying everything by 5. So it's going to be 5, 15, 25, 35. So everything's being multiplied by 5. So over 1, up 5. Over 1, up 15. So now I'm going to be way off the chart and somewhere up there. So notice how slender this curve is. And if I do the same on our side, it's really zoomed out and really stretched out. Oh, that was a bad example there. Let's erase that. I don't want to show it that bad off. And again, it's going to go up and out to the left like that. Okay. So again, very quick way to transpose it there. All right, now I'm going to show you another form here. Okay, this is intercept form. So we're talking about where it crosses the x-intercepts. And this is the equation we want to get into. Notice we have it in factored form, so we could easily get two solutions to x-intercepts. So first thing I'm going to do is take out this 1/2, because I want that x squared to be a 1 value. So I have 1/2, and if I divide out a 1/2, I have x squared. 1 divided by 1/2 is simply 2. And then 4 divided by 1/2 is going to be 8. And again, you could check by distributing. 1/2 x squared is 1/2 x squared. 1/2 times 2x is negative x there. And 1/2 times negative 8 is negative 4. Okay, now, what can I do with this? Well, I can factor that very quickly. X minus 4 and an x plus 2. Okay? So now I say, all right, what does that mean? Well, if I solve this and I set it equal to 0, we know that we can set x minus 4 equal to 0 and x plus 2 equal to 0, and very quickly get x is equal to positive 4 and x is equal to negative 2. So I have solutions at positive 4 and at negative 2. Well, since we know that all parabolas are symmetrical, we can basically find the average between those 2 points. So you could graphically look, say, oh, where's the middle at? Well, if they're 6 apart, I can put a dashed line right down the middle, 3 away from both of them. Or you could simply off to the side say, all right, let's take those 2 values, 4 plus a negative 2, and find the average. And we have there 2 divided by 2, which is 1. So on the x-symmetry, x equals 1, we found the average, and that's the middle. So if we know the x value of the vertex is 1, because it has to be in the middle, we could take 1 and plug it back into the original equation. So we have 1/2 times 1 squared minus 1 minus 4. And what do we have here? We have 1/2 minus 1 minus 4, and we're going to have negative 4.5. So my vertex is 1 comma negative 9/2. And I'm just going to put it as an improper fraction. So put that on the graph here. 1 and negative 4.5, right about there. And notice if I had a y-intercept, I could add that by my c value of negative 4, and symmetrical there. And again, notice the 1/2 a value. So my stepping is no longer 1, 3, 5, 7, but half. So multiply everything by half. 1/2, 3 halves, 5 halves, 7 halves, and so forth. So I'm going to go over 1 and up 1 half. So I went from 4 1/2 up to a half, to a 4, I mean. Looks good. And I'm going to go over 1 and up 3 halves, which is 1 1/2. Go over 1 and up 5 halves, and notice I end up there. So I can very accurately get the points I want. And notice, get a nice clean curve. So this method, we didn't complete the square, but we factored it and found the solutions and found the average, the middle, and got the vertex. So there's 2 other methods on how to graph quadratics. Again, you want to be familiar with all 3 of them. And vertex form is probably the most friendly because we could do the most with it. All right, for a homework, I want you to finish off these 2 problems. Try this one in intercept form, so I want you to factor it down and break it down, and complete the square with the vertex form, and then graph both of those. And that's where we'll pick up on our next lesson.